In this video, we are going to use the elimination method to solve linear systems of equations. This is the procedure we generally want to follow to do the elimination method. We first want to look for the least common multiple of the coefficients of either x or y in both equations. We then want to multiply the equations, either one or both of them, by an integer, so that way the coefficients of x or y, doesn't matter which one, are the same. Then we want to add or subtract the equations to eliminate one of the variables. And then finally we want to solve for the isolated variable and then use it to find the remaining variable. So let's do an example. We see here that none of the coefficients of x or y are the same. Therefore, we will want to find the least common multiple between the coefficients of x or the coefficients of y, so that way we can begin this process. So let's start by labeling these equations. This can be equation 1, this can be equation 2. And we see that the least common multiple between the coefficients of x is 12, but that would require us to multiply both of these equations by an integer, which we could do, and we can continue with that process and we would be right. But it would be faster to identify that we would only need to multiply equation 2 by a constant in order for the two coefficients of y to get to its least common multiple. So for the coefficients of y, 4 and 2, the least common multiple is 4. So equation 1 can just stay as equation 1, meaning no math required. In equation 2, what we want to do to it is we want to multiply it by 2. And if we do, we would end up with 8x plus 4y equals 4. So we multiplied every single term by 2. And now we can see that the coefficients of y are the same. And we can see that they're both positive coefficients of y. So we want to subtract one equation from the other to get our answer. So if we did 4y minus 4y, we would get 0y, which is just 0. We'd also have to do 3x minus 8x to get negative 5x. And finally, negative 6 subtract 4 is negative 10. If we then divide both sides by negative 5, we'd end up with x equals 2. And that's one of our answers. We then want to use this answer and sub it back into either of these equations to find the value of y. So we could say sub x equals 2 into equation 1. So we would have 3 times 2 plus 4y equals negative 6. 3 times 2 is 6, so we'd have 6 plus 4y equals negative 6. We then want to subtract 6 from both sides of the equal sign to move this 6 to the other side. So if we subtract 6 on the left side, it gets disappeared, and we're just left with 4y. And if we subtract 6 on this side, we would end up at negative 12. We then want to divide both sides by 4, and if we divided both sides by 4, we would isolate for y, where y would then be just equal to negative 3. And that's our other solution. So we could say, therefore, our answer, x comma y, the point of intersection for this system of equations, would be located at 2 comma negative 3. So we have a total of 6 questions to solve using elimination. Don't forget that every time new questions appear, to try the questions on your own, as that's the best way to prepare for the test. And then unpause the video and check your solutions. Good luck. So for question 1, we see that the coefficients of b are the exact same, just opposite signs. So if we added these two equations, equation 1 and equation 2, we would eliminate b. So we can do that right away. So let's add them. 2a plus 4a is 6a. If we add the b's, we end up with 0b, so we're just left with the 6a, equaling negative 1 plus 7 is 6. If we divide both sides by 6, we find that a is equal to 1. We then want to sub a equals 1 into either of our equations. So let's choose equation 1, but really it doesn't matter which one. So we'd have 2 times 1 plus 3b equals negative 1. 2 times 1 is 2, so we have 2 plus 3b equals negative 1. We then want to subtract 2 on both sides of our equal sign. And if we subtract 2 here, it's eliminated here, meaning we're just left with 3b. And if we subtract 2 on this side, we end up with negative 3. Then if we divide both sides by 3, we isolate for b, because 3 over 3 would be 1. And if we divide this side by 3, we end up with negative 1. So therefore, our a and b values are equal to 1 comma negative 1. Question 2. We see that the a values are the same, and they also are the same sign. So we, in this case, will want to subtract the two equations from one another. And again, we'll label this equation 1 and this equation 2. Maybe for this first equation, it would be important to point out that we are adding these equations. So here we're subtracting. 3a minus 3a is 0a, so we've effectively eliminated the a variable. And if we're subtracting, we need to do negative 2b, subtract 4b will take us to negative 6b. And also negative 1, subtract 11 will take us to negative 12. We then want to divide both sides by negative 6, and then we would isolate for b, which would be then equal to 2. And that's our first answer. We could sub b equals 2 into either of these equations, so I'll just pick equation 1. So we have 3a minus 2 times b equals negative 1. So we'd have 3a minus 4 equals negative 1. If we add 4 to this side, we end up with just 3a. But then we need to add 4 to this side as well. So we'd end up with 3. And then we want to divide both sides by 3, and we end up with a equals 1. So therefore, our coordinates of the point of intersection for this system of equation is equal to 1, comma 2. Question 3. We see we don't have anything common in our a values or our b values. So essentially we will want to find the least common multiple for our a's or our b's, so that way we can do the elimination method. So we call this equation 1 and this equation 2. Let's maybe find the least common multiple for our a values. So we know that that would be 12, right? So then we would want to take equation 1 and multiply it by 4 to get this to be a value of 12, or specifically negative 12. So we'd end up with negative 12a plus 12b is equal to negative 12. And we can call that equation 3. Then we want to take equation 2, multiply it by 3, so that way we would get 12a plus 6b equals 30. And that's equation 4. So now we can see that we have our a values have the same coefficient, one being positive, one being negative. Therefore, for these equations, we would want to add them to eliminate the a coordinates, because negative 12a plus 12a is 0. We then want to add these two terms together, so we would end up with 18b. And if we add these two together, we end up with 18. So if we divide both sides by b here, we'd end up with b equals 1. We then can sub this back into any of our 4 equations to solve for a. So let's sub b equals 1 into equation 1. So we have negative 3a plus 3 times b equals negative 3. So we have negative 3a plus 3 equals negative 3. We then want to subtract 3 from this side, so we'd end up with just this 3a. And if we subtract 3 on this side, we must subtract 3 on this side, and we would get to negative 6. We then divide both sides by negative 3 to isolate for a, so therefore a is equal to 2. Therefore, our answer, AB, the point of intersection of these two lines, would be at 2, 1. Question 4. We see that we can scale up to identify the least common multiple of, say, the y values by multiplying equation 1 by 5. So if we do equation 1 times 5, we would end up with 10x plus 5y is equal to 60. And that can be equation 3. And equation 2 just remains the same. So we can just rewrite that as 10x plus 5y equals negative 11. So now we have the y values are the same coefficient, so we can subtract them. So maybe we'll do a subtraction symbol right there, because 5 minus 5 would be 0y, which is 0. Then we want to do the same thing for x, so we'd have 10 minus 10, which happens to also be 0. So 0 plus 0 would just be 0 on this side, equals 60 minus negative 11. So the double negative cancels out. It's like we're adding the two positive values here, and we end up with 71. So 0 equals 71. That doesn't make sense, right? And that's right, it doesn't. Because that means that for any value of x and for any value of y that we could sub into this equation, this will never be true. So therefore, there is no solution. There is no value of x and no value of y where these two systems of equations, or these two lines in this system of equations, will satisfy these two equations. Meaning, these two lines are parallel, and there is no data point where they intersect. We have these last two questions here. So again, we want to follow the same process, even though we're now dealing with fractions. So let's start by labeling this equation 1 and this equation 2. So as we can see, for equation 1 and 2, we see that the coefficient of x is a quarter here and a half here. So if we multiply the equation 1 by 2, the integer 2, we will find that the coefficient of x will equal the coefficient of x here. So we'll take equation 1 and multiply it by 2. So we'd end up with 2x over 4 plus negative 4y over 3 equals 6. And we'll label that equation 3. Equation 2 remains the same. So we just have x over 2 plus y over 3 equals 1. And that's still equation 2. And just to simplify this before we do anything, we know that 2x over 4 can be reduced. 2 over 4, they both can be divided by 2, the numerator and the denominator, and this would end up being a half. So why don't we just go ahead and change this. Instead of being 2 over 4, we'll write it as 1 over 2, or x over 2. Now our coefficients of x are the same. So we will want to subtract these two equations. So x over 2 minus x over 2 is 0x, so which is 0. Then we want to subtract these two values. So we would have negative 4 over 3, subtract 1 over 3. And these are both coefficients of y, so I'm just going to common factor out the y. So we have 4 over 3y minus y over 3, or 1/3 y. And all of that will equal 5. So we see that we have a common denominator here. Therefore, we can just do this simple addition or subtraction in this case. Negative 4 minus 1 is negative 5. So we have negative 5y over 3 equals 5. So in this situation, we would want to multiply both sides by 3 and also divide both sides by negative 5. The negative 5's cancel out, the 3's cancel out, and coincidentally, the 5's here cancel out too, but the 1 is negative, so let's bring that negative to the numerator when we cancel this out. And we realize that we've isolated for y here, so y would just be equal to negative 3. We then want to sub y equals negative 3 into any of these equations. I vote for equation 2 because it looks the easiest. but any of these equations would work if we substituted this in correctly. So we have x over 2 plus negative 3 over 3 equals 1. Negative 3 over 3 is just negative 1. So if we're adding negative 1, that's subtracting 1, which is equal to 1. And then if we add 1 to both sides of the equal sign, we end up with just isolating x over 2, which is equal to 2. And then if we multiply both sides by 2 to isolate for x, we find that x is equal to 4. So therefore, x comma y would be equal to 4 comma negative 3. Finally, we have question 6. So this one looks probably the most confusing out of any of the questions here. But we can simply rearrange and isolate for x and y, or not isolate for x and y, but work them into a workable form. So let's take equation 1, and let's expand this fraction here. So we realize that this negative is leading over this entire numerator. So we have negative 1 over 4, and then we're going to expand the negative into the second part here and have negative x over 4 plus y equals 8. So let's bring this negative a quarter to the other side by adding a quarter to both sides. So if we add a quarter to the left side, it just gets eliminated over here. And if we add a quarter to this side, we end up with 8, which is the same as 8 over 1, plus 1 quarter. We can find the least common multiple between a 1 and a 4 and get 32 over 4 plus 1/4, which is equal to 33 over 4. And all of this is equal to negative x over 4 plus y. And this is still our equation 1. Comparing this to equation 2, we see that if we multiply equation 1 right here by 4, then we would end up with a negative x value here, matching the coefficient here. So let's do that. If we multiply this by 4, we'd end up with just negative x. Multiply this by 4, we end up with just 4y. And if we multiply this by 4, well, 4 times 33 divided by 4 is just 33. So let's call that equation 3. And let's compare that now to equation 2. So as we can see, the coefficients of x are the same, but they have also the same sign. So we want to subtract these. So negative x, subtract negative or adding x would be 0x, which is what we want. We then want to subtract these values of y from one another. So we would have 4y minus y minus 1 over 6. So we are subtracting this from this, and that'll all be equal to 33 minus 6, which is 27. We then just want to start the isolation process and find out what the value of y is. So to do this subtraction, we must find a common denominator. 4y is the same as 4y over 1. So let's multiply this first fraction by a numerator of 6 and a denominator of 6, so that way we have a common denominator with this denominator here. So we multiply the denominator by 6, we must multiply the numerator by 6, and the second fraction remains unchanged, and that's all equal to 27. So now we can do this subtraction, and maybe just because we're running out of space, let's continue the process right over here. So we would have 24y minus y, and then I'm going to expand this and distribute the negative to this negative 1 over here and end up with plus 1. And all of that's going to be divided by 6, which is equal to 27. We then can collect the two y terms right here. 24y minus y is 23y plus 1. and that's divided by 6. But if we multiply it by 6, the 2 6's in the numerator that we just added and the denominator here would be eliminated, because 6 over 6 would be 1. And if we multiply 27 by 6, we end up with 162. We now want to subtract 1 from both sides of the equal sign, so we end up with just 23y is equal to 161. And if we take 161 and divide it by 23, we find that y is equal to 7. And coincidentally, we were also dividing the left side by 23 to isolate for y. So now we found our value of y. And we can sub this into any of these equations, 1, 2, or 3, to solve for the value of x. I vote for equation 2 because x is to some extent already isolated. So y equals 7, we're going to sub that into equation 2. So we'd have negative x plus 7 minus 1 over 6 is equal to 6. So we'd have negative x plus 6 over 6, which is 1, equals 6. And then we want to subtract 1 from both sides, so we would end up with negative x equals 5. And then we want to divide both sides by negative 1. And we'd isolate for x, where x would be equal to negative 5. Therefore, x comma y is equal to negative 5 comma 7. And that's it for this video.